Jai Shri Gurudev. Good morning dear students. In the previous class we studied about nucleophilic substitution reactions and examples of nucleophilic substitution reactions. In this class we are going to study the mechanism of nucleophilic substitution reactions. Basically, the nucleophilic substitution reactions are molecular reactions. Therefore, breaking and making of bonds takes place. The breaking of old bonds and forming of new bonds is called as a mechanism. Here, the nucleophilic substitution reactions are classified into two types based on the nature of alkyl halides bond. Based on the nature of alkyl halide bond, that is based on the nature of alkyl halides. That is Rx. Based on this nature bond, the alkyl halides is classified into two types. That is means the mechanism is classified into two types. That is SN1 and SN2. These are the two types of reaction mechanisms. We are classified alkyl halides on the basis of bond, that is Rx bond. The SN1 is nothing but means the meaning of SN1 is unimolecular nucleophilic substitution reaction, and similarly SN2 means bimolecular nucleophilic substitution reaction. And we also say that substitution nucleophilic unimolecular, substitution nucleophilic bimolecular. Okay, that is substitution nucleophilic unimolecular. Similarly, SN2 means substitution nucleophilic bimolecular. So here these two mechanisms are takes place in different solvents. Generally the SN1, that is substitution nucleophilic unimolecular or unimolecular nucleophilic substitution reactions, is carried in polar solvents or heterotic solvents, and this SN2 reactions is carried in non-polar solvents. Those we are studying while studying the mechanism of these reactions. So both are very, very important for the purpose of examination. Definitely they ask anyone among these two. Now take first one, SN1, that is unimolecular nucleophilic substitution reaction. The first reaction mechanism is SN1, that is substitution nucleophilic unimolecular reaction. So this SN1 reaction follows the first order kinetics, and this reaction is carried in presence of polar solvents or aprotic solvents like water, acetic acid and alcohol. Aprotic solvent is nothing but a solvent which donate or release only one proton when it is dissociated. For example, observe water H2O, after which is dissociating you get H plus and OH minus. So here we get only one proton, hence the water is called as aprotic solvent, and you know this is a polar solvent because there is high electronegativity difference between oxygen and hydrogen. Similarly, take acetic acid, that is CH3COOH. So after ionizing this one you get CH3 COO minus plus H plus. So this is the ionization of acetic acid. Here you get only one proton. Similarly, you take alcohol like methanol or ethanol, anyone. This alcohol is also a protic solvent or aprotic solvent. This is on ionizing you get CH3O minus plus H plus. So here you get only one proton in all these three solvents. Such type of solvents is called aprotic solvent. Remember, the SN1 reaction is carried only in aprotic solvent and it follows first order kinetics. Now example for SN1 reaction is take hydrolysis of tertiary butyl alcohol. Hydrolysis of tertiary butyl bromide. hydrolysis of tertiary butyl alkyl halide, that is we are taking tertiary butyl bromide, very important. Now take reaction. Before knowing to the mechanism, we are studying the mechanism of SN1 and SN2. Before knowing mechanism, take reaction. Here the reaction is hydrolysis of tertiary butyl bromide. That is take tertiary butyl bromide. This is the tertiary butyl bromide. So observe how to write the tertiary butyl bromide like that. Place here bromide Br, and you know in this corner of the center there is a carbon, and each terminal is indicated by what? CH3 groups. Write CH3. So this is tertiary butyl bromide. Tertiary butyl bromide. So hydrolysis. Now you have to hydrolyze this tertiary butyl bromide with aqueous NaOH, aqueous sodium hydroxide, AQ sodium hydroxide. On hydrolysis, this tertiary butyl bromide with aqueous NaOH, you get tertiary butyl alcohol. Tertiary butyl alcohol. This is the one of the reaction, that is nucleophilic reaction. So observe here, Na and OH becomes what? NaBr, and this OH get added to this one, that is CH3 bond C bond CH3 bond CH3 bond, in place of Br substitute OH plus Na and Br becomes NaBr. So this is the example of hydrolysis of tertiary butyl alcohol, tertiary butyl bromide for unimolecular nucleophilic substitution reaction. Now this reaction occurs two types of mechanisms, or this mechanism undergo two steps. The first step is hydrolysis of this tertiary butyl bromide and formation of carbocation, that is planar carbocation. And the second step is attack of nucleophile to the planar tertiary butyl carbocation. So those two steps are very important. And here in this mechanism, the first step only the rate determining step. Those we are studied in detail in mechanism. Listen carefully, very important. The first step in mechanism is hydrolysis of tertiary butyl bromide. Tertiary butyl bromide, you know the tertiary butyl bromide is CH3 bond CH3 bond CH3 bond Br. Okay, this is the tertiary butyl bromide. So here it will be hydrolyzed. Observe the halide is more electronegative than carbon. Therefore, the bonded electrons between bromide and carbon moves towards what? Bromide. Therefore, you get carbocation and bromide anion. This is the hydrolysis step. The step is slow step and irreversible step. So irreversible step, and this is the rate determining step. Remember, the first step is the rate determining step. The rate of the reaction is depends only on the first step. What you get? CH3 bond C bond CH3 bond CH3. So after ionizing, here the carbon carries positive charge plus Br minus, that is bromide carries negative charge. You get tertiary butyl carbocation. Its name is what? Tertiary butyl carbocation. And this is bromide anion. Here we are taking tertiary butyl bromide. Tertiary butyl bromide. So observe, for this carbon the hybridization is sp3 because 1, 2, 3 there is 4 bonds, where ends the hybridization is sp3. But here observe 1, 2, 3, only 3 bonds in carbocation, hence the hybridization is sp2. When the carbon atom having sp2 hybridization, its geometry is trigonal planar like that. Its geometry is trigonal planar. So remember, the carbocation is planar in nature. So the second step is step 2, that is attack of nucleophile to the tertiary butyl carbocation. Attack of nucleophile. So here nucleophile is OH minus, that is obtained by what? NaOH. Oh, after ionizing NaOH. So observe NaOH. On ionizing you get Na plus OH minus, right? So this is the nucleophile in this reaction. So that is attack of nucleophile to carbocation or tertiary butyl carbocation. You can write like that. So in this step, take tertiary butyl carbocation, that is C bond CH3 bond CH3. Okay, this is the tertiary butyl carbocation plus the nucleophile is what? OH minus, right? OH minus. This will attack the carbocation like that. You should show the arrow mark. You should show, otherwise you don't get the mass or you can lose the mass. So this is the attack of nucleophile to the tertiary butyl carbocation. This is the fastest step. Means the step of the reaction is fast and this is not a rate determining step. After attacking this one, what you get? C bond CH3 bond CH3 bond CH3 bond OH. So you get what? Tertiary butyl alcohol. What is name? Tertiary butyl alcohol. Tertiary butyl alcohol. This is the reaction mechanism. Very, very important. Now take second one, that is SN2 reaction. So in the mechanism of SN1, I told you the first step of the mechanism is only the rate determining step. Therefore, for SN1, rate of the reaction is directly proportional to the alkyl halide. Independent of nucleophile. So here in the first step, the tertiary butyl bromide is ionizing, you get carbocation and bromide ion. That is the slowest step and rate determining step. There the rate is determined only the nature of alkyl halide and independent of the nucleophile, that is OH minus ion. Therefore rate is directly proportional to the alkyl halide. That is rate is equal to the order of the reaction is what? 1. Hence the rate of the reaction is 1. And you know it follows first order kinetics. First order kinetics, hence the rate of reaction is 1. So that we call unimolecular substitution reaction. Now take bimolecular substitution reaction, that is SN2. SN2, that is substitution of nucleophilic bimolecular reaction. Bimolecular example for SN2, that is bimolecular nucleophilic substitution reaction, is hydrolysis of methyl bromide. This is the SN1. Now we are going to study SN2. The example for SN2 reaction is hydrolysis of methyl bromide. Hydrolysis of methyl bromide. Now take the reaction. So the methyl bromide is, you know, that is CH3 is nothing but methyl group, and take bromide. This methyl bromide reacts with aqueous NaOH, sodium hydroxide. Here the Na and Br becomes NaBr and CH3 and H becomes NaOH. That is CH3 bond OH plus NaBr. What you get from methyl bromide to methanol? Methyl bromide, which is reacts with NaOH, sodium hydroxide, aqueous, get methyl alcohol, or we call methanol. Here, this mechanism follows only one step, or it takes place only in one step, and this SN2 reaction is carried in non-polar solvents, but SN1 is carried in polar solvent. Now observe the mechanism of the reaction. So here the formation of new bond and breakage of old bond will be takes place simultaneously. It means the nucleophile will be attack opposite side of the leaving group. It means back side of the leaving group. Here the leaving group is bromide. Here the leaving group is bromide. You know, because bromine is more electronegative than carbon, hence this bonded electron moves towards bromine. Okay, so this can be written like that. Observe carbon and the bromide. Here there is 3 hydrogens. You know, 3-dimensional representation of alkyl halide. One bond is above and one is below and one is unplane. Okay, so these 2 bonds are unplane and one is above and one is below. There is 3 hydrogen. Write 1 hydrogen here and the second hydrogen here. This is the 3rd hydrogen. This is the 3-dimensional representation of this methyl bromide. Here the nucleophile is OH minus. That is right. OH minus is a nucleophile. OH minus. Always write the negative charge on oxygen only. So here observe this nucleophile will be attached to the carbon and leaving of this bond or breaking of this carbon bromine bond will be takes place simultaneously. And remember, the nucleophile will be attacked the back side of this leaving group. Therefore, after attacking this nucleophile and leaving this bromide will not take place at single step. It means slowly this OH and carbon bond is formed and carbon bromide bond is slowly broken, means partially broken. So that is called intermediate or transition state. So observe what you get in transition state. So Br get attached to the carbon, OH minus get attached to the carbon, that is, I write like that, partially formation of carbon oxygen bond, and here there is one hydrogen, that is first hydrogen, then second hydrogen and third hydrogen. And this carbon bromine bond will be partially broken, that is like that, writing like that. So here observe all these 3 hydrogens, 1, 2 and 3. These 3 hydrogens are in same plane, and this OH is above and Br is below, or OH is below, Br is above. Like that, let you assume this is the plane of the carbon and 1 hydrogen is above, remaining 2 hydrogens are below, and the right 2 OH and Br, these 2 atoms get the opposite side, like that. This is the assumption, and you get this is the transition state. For this one, carbon carries positive charge, okay, and this bromide carries positive charge, that is delta minus and delta minus, higher delta plus, like that. We are writing this is the transition state. In the second step, this carbon bromine bond is completely broken and OH carbon bond, means oxygen carbon, is completely formed. So here that is formation of bonds, HO bond C. After this leaving you get carbon, and again the 3-dimensional representation of bonds will be remain same. That is H. One is below the group, that is H, and this is the 3rd hydrogen, like that. And the leaving group is Br minus. Okay, this is the mechanism of SN2 reaction. This follows only in single step. Here the rate of reaction is depends both the alkyl halide and nucleophile. Hence the order of the reaction is 2 and it follows second order kinetics. Hence the rate of reaction is given by, that is rate of the reaction or rate is directly proportional to the nucleophile OH minus, and the rate of the reaction is defined also alkyl halide, that is CH3 bond Br. In both the reactants, the rate is depends. Its order is not 1. Its order is 1. So had the orders while finding the rate of the reaction is, hence order of the reaction is equal to 1 and 1, that is rate. 1 plus 1, that is equal to 2. So this is the order of reaction for SN2. Hence we call bimolecular nucleophilic substitution reaction or second order reaction. This is the mechanism, very important. So observe here, ಇಲ್ಲಿ ಏನಾಗಿದೆ ಅಂದ್ರೆ ಅಬ್ಸರ್ವ್ OH ಅನ್ನೋದು ಈ ಕಡೆ ಇದೆ ಅಂದ್ರೆ ರೈಟ್ ಸೈಡ್. So Br is in right side and OH is in left side. And the observing product case OH is left side and Br is right side. Here the configuration is reverse. Hence you get opposite configuration of the molecule. Those differences we are studied in while studying the difference between SN and SN2. And observe here one more point is the primary carbocation is only more favorable for carried SN2 reactions. Hence the order of the reaction or the order of occurring SN2 reaction is primary carbocation is more reactive, then secondary carbocation and tertiary carbocation. This is the least reactive. Before that the methyl carbocation is more favored. Hence we are taking methyl bromide here. But in SN1 reaction this is exactly opposite. In SN1 that is tertiary butyl carbocation is more favorable towards SN1, then secondary butyl carbocation and primary butyl carbocation or primary carbocation, and the last one is methyl carbocation. This is the order of reaction towards SN1. So these we are studied in detail while studying the difference between SN1 and SN2. Now take the difference between SN1 and SN2. Difference between SN1 and SN2 reaction. Difference between SN1 and SN2 reaction. So what is mean by SN1? It is unimolecular reaction. It is unimolecular reaction and it is bimolecular reaction. Bimolecular reaction. Then the second one is it follows first order kinetics, right? Follows first order kinetics. First order kinetics, and this follows second order kinetics. Hence the rate of reaction is 2, right? Here the rate of reaction is directly proportional to the nucleophile. Not nucleophile, alkyl halide. Rate is directly proportional to the nature of alkyl halide. That is alkyl halide in SN1, right? Similarly, here the rate is directly proportional to the water. Nucleophile and alkyl halide. Hence the order of reaction is what? Here order is equal to 1 and here the order of reaction is what? 2. Okay, then the next one, order of reactivity of alkyl halide is follows, that is order of reactivity of alkyl halides. Order of reactivity of alkyl halides for SN1 is what I know, tertiary alkyl halides is more favored than secondary. Tertiary alkyl halides is more favored than secondary, which is more favored than primary, and which is more than methyl. This is the order of reactivity of alkyl halide. Then here exactly opposite, that is order of reactivity of alkyl halide is methyl alkyl halide or carbocation is more favored than primary, which is then secondary, and which is then tertiary. This is the order of reactivity of alkyl halide. Then here you get a racemic mixture. Is obtained, and here you get inversion in configuration. Inversion configuration. So here observe what is meant by racemic mixture. Racemic mixture is nothing but equal mixture of D and L configuration. Equal mixture of D and L configuration is called racemic mixture. D is nothing but dextro-rotatory, means clockwise direction. S is nothing but levo-rotatory, means anti-clockwise direction. In SN1 reaction, while doing the mechanism, we get carbocation, right? In first step, this carbocation having sp2 hybridized. sp2 hybridized means planar in nature. Therefore, the newly coming nucleophile may attack either above the carbocation or below the carbocation, so that you get two compounds having same molecular formula but differ in their rotation of plane polarizer, right? Such compounds we called as a racemic mixture, that is the combination of D and L compounds. But in SN2 reaction, you get inversion in configuration. It means for carbon, one side is there is a Br atoms and another side, that is exactly opposite side, there is a OH group, right? After leaving Br, you get the carbon oxygen bond. Here you get the inversion configuration, means reverse configuration. Bromine ಯಾವ ಕಡೆ ಇದೆಯೋ ಅದಕ್ಕೆ opposite OH ಇದೆ. Hence it called inversion in configuration. These are the some differences between SN1 and SN2. There is so many differences. We are given only few. So you can write any 4 or 3 among these. If they ask for 4 marks, you should write at least, sorry, they ask for 2 marks, you should write at least any 2 out of these 6. These are the some differences.